Hi there. Today I want to introduce this paper FixMatch, Simplifying Semi-Supervised Learning with Consistency and Confidence. It's published in New Apps 2020. And the authors are from Google Research. You can see it has 9 authors and two first authors. The ideas are very simple. Here, never mind, you can just see this one. You can see for semi-supervised learning, it contains two components. One is for the label data, and another one is for the unlabeled data. For label data, it namely compute the cross entropy, and you can see here the labeled batch given a mini batch. We have the x and the probability, or not probability, the ground truth one hot label is one hot vector, namely the y. So we compute the cross entropy given x, uh, to compute the py given x. Then we optimize the cross entropy. It's very standard method. Here, alpha represent data augmentation because to improve the accuracy, you need to use some data augmentation techniques. So this one is very standard. And for the unlabeled data, because for label data, it may only have like 400 images, because for CIFAR 10, we have 10 categories. Each category we will use 40 labeled images. Then may only use 400 labeled images. And for the unlabeled data, we can see it also computed the entropy between two distribution. The one is the QB tilt. The QB tilt is first we have the QB. The QB is given the unlabeled data. We get the output predict probability vector. We use the QB to represent it. Then we take the argmax, namely convert it to the one-hot labeling. So it's a one-hot labeling vector. Then compare with the py given AUB. Here the A is a strong data augmentation, like cutout and rand augmentation. So it's a strong data augmentation. And the entropy we want name, so it represents that one. Given an x, we may have some weak data augmentation around it in the feature space, in the hidden space. For some strong data augmentation, it may be far away from the real x. Here is the strong augmentation. This one is a weak augmentation. But we still need to compute the consistency regularization between this one. Namely, we also want the predictions of this strong augmented x to be as close as possible to the real data. So this is the idea behind this one. We want to compute it. But when do we consider this term? When do we add it to the label to this one to optimize the model? So they use this indicate function when the max probability larger than a threshold. Yeah, namely if the prediction is too low, the accuracy is too low, then you should not treat it as a correct prediction. So it's just from the title. You first need to consider the consistency, confidence then apply the consistency. So when it has a high confidence, you can apply this consistency with this one. So finally, the computing the pseudo label of the fixed match is that you can see we compute the cross entropy loss for label data, and then for unlabeled data we compute the prediction after applying weak data augmentation of UB. So this is up it will apply the weak data augmentation. And then we compute the cross entropy with the pseudo label and the confidence for the unlabeled data. First, the confidence should larger than a threshold. Then we apply this consistency regularization as the unlabeled loss. Then we add the label loss with the unlabeled loss with a coefficient. And so it's the whole framework, very simple. Okay, so here the pseudo labeling may produce a natural curriculum for free. This is the whole idea. I think we can. Then I just finished the introduction. Thanks.